So today we're going to apply what we know about transformations, and we're going to apply them to exponential functions. So we're going to be graphing exponential functions, and we're going to start with translations. Translations are a vertical or a horizontal shift. So if I have my general exponential function, y is equal to b is the base of the exponent, x is my independent variable, plus some constant c. If I am inside the function, that is a horizontal shift, and it is counterintuitive. It means it's going to move in the opposite way of the sign. Counterintuitive. So what that means is, if c is positive, we are going to shift to the left. And if c is negative, we're going to shift to the right. My standard exponential function crosses the y-axis at 1, and then if I go to the right one, I go up the amount of the base. So let's say the base is there. If I go to the right one, that's where I'm crossing. Try to make that a little bit better. So if I have a base b for my standard function, I am crossing at 1, b. That is on the graph. That's without any transformations. So what this will do is it's going to shift this function either left or right when I'm done. If I want to try a quick example, if that is y is equal to 2 to the x plus 3, let's see if we can try that example here. Alright, so I've cleared my screen. I just want to focus on this one. Y is equal to 2, and this is the exponent, x plus 3. What this says is I'm shifting horizontally by 3, and since it's positive, I'm moving left 3. So my standard function would cross the y-axis at 0, and if I move to the right by 1, I would go up 2. So I'm going to dot that in. Here's my standard function. So he would kind of be dotted in here. Well, a little bit better than that, and he would go up like that. Okay, what this guy is going to do is take this function and shift everything to the left by 3. So instead of being at 0, 1, I'm moving that point over by 3 units. Instead of being at 1, 2, I'm moving everything over by 3 units. So I am now at negative 3, 1 and negative 2, 1. Exponential functions have a horizontal asymptote. Since this was a horizontal shift, the asymptote is still y is equal to 0. So that did not change. The second shift, the second type of translation, is a vertical one. And that's when I have the constant outside of the function. So that's going to shift everything up and down. It's a vertical shift. I can write that fast enough. This time it's a direct read. When c is positive, we're going to shift up. When c is negative, we're going to shift down. So, but for vertical shifts, this also shifts the horizontal asymptote. So that's what you have to remember. When you are shifting things up and down, the horizontal asymptote will shift as well. So over here I'm going to graph this one. Y is equal to 3 to the x minus 4. That means I'm going to shift down by 4, and my new asymptote is going to be at y is equal to negative 4. So I'm going to put that in. Here's my new asymptote. Everything else is drawn relative to it. So on the y-axis, I am 1 point above the asymptote, and then if I move to the right, starting from here, if I move to the right 1, I'm going to go up the amount of the base. If my base is 3, that means if I move to the 1, I go up 3, and that point is on the graph. Everything has been shifted down by 4 units. And then we draw the same parent function. That line is supposed to be going through that point right there. It's kind of tough to do on the iPad, but this is y is equal to 3 to the x minus 4. So just remember, in this case, that point is at, looks like it's 1, negative 1. And we are 3 units above the horizontal asymptote. My first point is 1 unit above the horizontal asymptote. So now we're going to apply two translations to this function. I have a base of 4, my exponent is x minus 2, and I'm shifting minus 3 on the outside. So that means I'm moving to the right by 2, because it's inside the function, so it's counterintuitive, and I'm moving down 3. So my standard function, centered at the origin, would be 1 unit above. If I want to graph the standard function here, I would cross the y-axis at 1, and then if I move to the right 1, starting from the origin, if I move to the right 1, I go up the amount of the base. So the point 1, 4 is also on the original graph, the original parent, 1, 2, 3, 4. So I'm just going to kind of sketch him in. Now this guy, he's going to move down 3. Everything shifts down 3. So my horizontal asymptote is at y equals negative 3. Everything shifts. But not only is he shifting down 3, he's going to move to the right too. So down 3, right 2, there's my new point. It's a 1 above for whatever we do. Until we do dilations, your original point is always going to be 1 unit above the horizontal asymptote. And then from there, if I start at the horizontal asymptote and I move to the right of that first point, I go up the amount of the base, 1, 2, 3, 4. So he's going to be right there. And if you look, it should be down 3, right 2 from your original guy there. 1, 2, 3, 4. There he is. So we've taken our original function and we've shifted everything down 3 and to the right 2. And that's my new function. Y is equal to 4 to the x minus 2 minus 3. So we're going to cover reflections as well. A reflection, when I have a negative 1 as a coefficient, outside of the function, it affects your y values. So what that means is it's going to reflect over the x-axis. Reflects over x. So if I just want to sketch this very quickly, here's my x, here's my y, and my regular function looks like that. Well, I'm just going to do it. It doesn't like me doing the dots. Then my reflected function is going to be the mirror image over the x-axis. The domain doesn't change. It's all reals. My range now is y is less than 0. If I have this, y is equal to b to the negative x, that reflects it over the y-axis. So if I want to put a sketch in here, x and y, my original guy looks like him, and my new one's going to cross at positive 1, but he's going to be reflected over the y-axis. In this case, the domain stays the same and the range stays the same as the original. The domain is still all reals, and the range is y is greater than 0. So let's graph this example here. I have two transformations going on. I have a reflection outside of the function, and I have a shift of 3 inside the function. So the reflection means it's going to reflect over the x-axis. Reflect down. We always reflect first, then we move things. And then the translation, it's inside the function, it's counterintuitive, so it's going to move left 3. So my original function has a base of 2. My original function crosses the y-axis at positive 1, and if I move to the right 1, I go up from the x-axis the amount of the base. So these are just points on my original function. I'm going to reflect it over the x-axis, so I'm going to reflect it down, and I'm going to shift every point by 3 units. So instead of him, he's going to be here, and then he's moving left 3. So that point is here. The next point, instead of up 2, he's down 2. but now he's to the left 3. So relative to each other, they should be in the same relative spot as the original. If you look, my original 2 points were just kitty-cornered from each other. They still are. Okay, my horizontal asymptote hasn't changed because there was no vertical shift. So the horizontal asymptote is still y equals 0, and my new function is going to increase like that, or decrease like that, I guess. The domain is still all reals, and the range is now y is less than 0. So we'll do one more for our notes, and then we'll practice more in class. Here I have f of x is negative 3 to the x. Now I have a vertical shift. The vertical shift is going to change the horizontal asymptote. My new horizontal asymptote is going to be at y is equal to 2. So we're going to start there. And I also have a shift. I also have a reflection over the asymptote. Remember, you always reflect first, and then you shift it up, which results in a reflection over the horizontal asymptote when you're done, because you move everything up. So the negative 3, instead of being 1 unit above the horizontal asymptote, we're now 1 unit below. That's our starting point. And if I move to the right, instead of moving up 3, I'm moving down 3. 1, 2, 3. So here's my new function. He's only shifted up, but he's reflected down. And again, we're going to practice more of these in class so you get the hang of it. The domain is still all reals, because it always is for exponential functions. This time my range, if you look at your horizontal asymptote, y is less than 2. Y can be 0 in this case because I've shifted everything up by 2. So that's a quick introduction to graphing exponential functions using transformations, and we're going to work on this more in class.